Thank you very much. Good afternoon, everybody. What I'd like to do perhaps today is take you on a slightly different journey and think about the things we've been hearing in the sense that Jean-Francois and Don Cool earlier said we need to think about how to integrate protection of the environment into existing situations and how we deal with them. And one of the things I'd like to do using some case studies kindly provided by my co-authors is to think about the guidance and the advice that we can think about putting forward, and so that's what this presentation is about, so we'll see how that goes. One of the things I'd also like to do is take the opportunity to look at how the derived consideration reference levels that Carl Magnus mentioned earlier this morning, how they apply, and then look specifically at how they could apply in the context of existing sites. I'm going to go through some case studies, but I'm only going to very briefly touch on those. I want to just pull out the lessons from those, and then I want to think about how we can actually put this into some guidance that we might be able to produce in the near future. You've heard lots already today about existing exposure situations, and I don't intend to go through all of the different parts of this again. Mike's just given you a very nice overview of the different types of sites that we have to deal with. It's just that remembering that we have to deal with all of these different sites. And the idea behind this is that in many cases, they're going to be controlled by the assessments for humans. In many cases, what we're looking at here is not necessarily trying to control these sites from the protection of the environment perspective, although I'll come back to that later on. This is about trying to make sure that if you have choices that you can make, that those choices also take into account the impacts on the environment in terms of the wildlife species that may be present in those environments. So it's about trying to capture where we can gain benefit from both of these occasions. In most cases, we've seen graphs today from Don and from Jean-Francois, where you can see how, in an existing situation, you would expect that as you do something, as you optimize protection for humans, you should be pushing, radiologically, you should be pushing the dose rates down for humans. You're doing that because you're basically removing the radioactivity from those sites. So it makes sense that in those contexts, you're actually also going to benefit the wildlife because you're removing the radioactivity. So the doses to the wildlife will also reduce. However, in doing that, you may cause more damage to the environment in the way that you extract the material. So I use a very simple and crude example. Going in with a bulldozer, you're going to remove the seed bank and everything else that you might need in that environment. So this is about trying to work out how you can provide the guidance and the advice in the types of approaches that you could use. And the beauty, I would like to argue, of having an integrated system of protection now is that we can use the derived consideration reference levels, which I will describe in more detail in a minute. We can use those to help us to understand the consequences of our actions on the wildlife species that we're interested in. And that's something where you can start to demonstrate what the consequences may be, and you can start to think about how you can justify both the improvements for humans and wildlife. So you saw this earlier from Carl Magnus, and again, what I really want to focus on here is the derived consideration reference levels. And as we mentioned earlier, these are bands of dose rate at which you would expect to, or you might expect to find deleterious effects on particular types of wildlife. Now, at the moment, they're based on the reference animals and plants, the 12 that we've identified for the purpose of working out what these derived consideration reference levels are. But they give you a way of looking at the environmental impacts that you might have from these contaminated sites. Just to give you an illustration then, I'm going to go quickly through emergency and then planned and then existing exposure situations. But the concept behind these DCRLs and how you apply them, which is described in publication 124, is that you can get information from doing assessments. So we have the ability through publication 108 and publication 114 on being able to do assessments for wildlife. And what you're looking at in this context is we've done an assessment, we've worked out what the dose rates are, now we can start to see what the kinds of effects you might see under emergency or planned or existing situations can be. And this just gives you an example. for emergency situations. And what you can see here is that over time, as the emergency evolves, you're probably, not necessarily, but probably going to exceed the DCRLs, and you can start to think about the consequences of that. And then over time, this will turn obviously into an existing situation, and again, you can start to understand where you are in relationship to the DCRL. Obviously, a couple of things to mention in this case. It's not necessarily always about trying to protect the wildlife and so on in the case of an emergency. This is about being able to plan what might happen or to assess what might happen in an emergency situation that you're predicting as a scenario in your development of the site and so on. And obviously also what we're looking at here is the change to the existing situation and how that will influence, as I'll show you in a moment. In terms of planned situations, Carl Magnus mentioned this earlier, the DCRL is about places where you might see deleterious effects. So if you're planning to deliberately release radioactive materials into the environment, then the idea is that you would plan not to go into those bands where you would see deleterious effects. And obviously what I'm looking at now is how we do this for existing situations. So this is what I want to focus on now. And if you look at publication 124, what it describes in this process is how you can actually use these DCRLs, and that the expectation is that you would be trying to move, in terms of wildlife dose assessments, towards the DCRL, assuming you're above it, perhaps into it, and maybe even below it, depending upon the amount of cleanup that you actually do. But in this, we also mentioned the idea that you have to consider not just the radiological aspects of this, but also the non-radiological aspects and consequences of doing this cleanup. And that goes back to what I said earlier about trying to make sure that we do more harm. Sorry, do more harm? That's the wrong way around. We do more good than we do harm in trying to clean up these sites, okay? It's late in the day, that's what I blame it on. You saw this earlier as well in terms of the DCRLs. I just put this up to remind you what they actually are and where they're coming from. So for the types of mammals that we're interested in that are represented by the deer, the duck, the rat, and so on, and for birds represented by the duck, you're looking at DCRLs around about 0.1 to 1 milligray per day for the actual dose that we're interested in. And these have been set, as I said, based on information on effects or a precautionary approach, as you'll see in a moment as well. But it gives you an idea of where they've come from, and as I said, what we're looking at here is using these RAPs, these reference animals and plants, to start to represent types of organisms in terms of the concept. So mammals being represented by the deer and the rat and so on. In doing so, we can then start to think how we can use these numbers. We now have some numeric criteria which we can assess against. And so I just give you the table. This is just one I picked out of publication 108 just for demonstration. And here you can see that if we had significant dose rates, you might actually be seeing mortality as described in the document, or potentially reproduce effects on reproduction, etc., and so on. And as I said, the idea behind this is you now have an idea of what the dose is to your wildlife, so you can now start to see, well, what if I do some cleanup? Where am I going to take that dose rate? Am I going to reduce it down to a band that I'm interested in that's actually going to reduce the impact on the wildlife? In some cases, you might go into the band, and as I said, some cases you might go below the band. What's worth noting, however, is that some of these boxes we don't have any information on in terms of the wildlife effects for the particular RAP that we're looking at. And Carl Magnus mentioned this morning about the idea of actually looking through the new task groups, looking at refining these DCRLs and making sure that we've got robust information on which we're basing that location of the DCRL. But that aside, at the moment, the philosophy behind this, I think, is appropriate. We've got these DCRL bands that are bands of potential effects, and that's where we want to avoid being or become below, depending upon the exposure situation that we find ourselves. This is just, it's not an exhaustive list. This is just to give you a flavour of the sorts of things that we're going to need to know about when you're doing the assessments. So you're going to need to know something about the radionuclides, the source term that we're interested in. You're going to need to know something about the area of contamination. You're going to need to know something about the location and position of that contamination in the environment that we're working in. In terms of humans, you're going to need to know how many people are affected or potentially affected, and the same with the wildlife and the population size for the wildlife. Up to that point, anybody notice anything interesting? That's the same to me as if you were doing a planned assessment or an existing assessment or any other type of assessment. So there's no difference in the basic principle in this in the context of these different exposure situations. What does differ, potentially, are your engagement with stakeholders, and we've already heard that today, this afternoon, in terms of the context of using these or working with these existing exposure situations. And that's where you may end up with slight differences in opinion and the things that you're actually trying to tackle, which become site-specific in this process. So that's something just to bear in mind, I think, that these assessments are not necessarily complicated or more difficult than any other form of assessment that you would do. They're just being placed in the different exposure situations. I'm going to go through 3 examples of sites at the moment, just to have a look at them. This one here is Andreeva Bay in northwest Russia. It's currently being used as a storage waste site, and our Norwegian and Russian colleagues have been working at this site looking at the impacts of cesium-137 and strontium-90 on both humans and wildlife. So we have a number of resident species in this area that we're interested in this particular location, various types of grass, birch trees, earthworms, amphibians, and mammals. And what's interesting about these sites, if you start to look at the actual doses to the organisms, the numbers I want you to focus on, not the number, but the fact there's some bold in these tables. What those bold numbers are telling you is that the DCRL for the equivalent RAP for those species of interest is actually being exceeded. So in these sites, these existing exposure situations, these wildlife species are actually exceeding the DCRLs. So this is an example where we would expect to see some potential impacts on those wildlife species. Just to mention that we have over here the site that's listed as conversion and conservation. So what we have here are sites that are being converted, they're actually being worked on to actually improve the situation, and other areas that are being left at the moment in terms of the potential cleanup. And the key findings from this work, I've summarized, well, I've gone through it very quickly and I've summarized it down. The key thing with this is that when you do the dose assessment for humans, all of the dose assessments for humans for the criteria that are applied at that location, all of those are being met. But for individuals of the wildlife species of interest, some of them are exceeding the dose constraints, sorry, the derived consideration reference levels that we're actually using. But something I want you to think about with this is actually we have to start thinking about scale of impact, and the populations might not be very large. So I'm going to use you lot as an example. So in this room, I think Chris said earlier, there are about 400 people in this room. So compared to the population of Seoul, if we were all to be killed off, it's not going to make that much difference to the population in Seoul. However, of course, you are all rare and endangered species because you're all radiation protection professionals concentrated in one location. So we still might need to think about how individuals of particular species of particular value, and that goes back to your stakeholder situation, how those individuals may be important to that community that we're actually thinking about and we're actually trying to clean up. Furthermore, it might not be the radiological hazard that's actually causing the problem. I mentioned this already. It might be the actual conversion processes that are going on in that site that are actually causing the impact on that local population. So again, we can think about optimizing the actual process of trying to clean up that site. Now remember, I said that the DCRLs might have no information in them and so on. So one question I would also ask at this point is, if I was doing the assessment for real and thinking about wildlife in this context, is what observable effects have I actually seen? Have I actually seen anything where I might be concerned about those individual wildlife that we're looking at? And you might start to think about potential transgenerational effects and so on as well in this process. And that leads me on to the next case study, which is at Mayak. And here we're thinking again about things like cesium-137 and strontium-90 as the principal radionuclides of contamination that we're interested in. And we're looking here at the historic releases. So we're looking at a complex site again, but in this context, we both have planned and existing exposure situations in and around Mayak. So again, the thing here, we can go out and we can look in the environment, we can take measurements, we can do dose assessments. Now, what's interesting about this particular site is that here, the fish biota and so on that were examined, the invertebrates and so on, the aquatic invertebrates and so on, were all assessed in terms of their dose rates, but they were also investigated in terms of effects on things like weight, age, sex, etc., and also in terms of their reproductive endpoints and so on. And the fish were showing impacts at dose rates of around about 0.2 milligrams per day. That's actually lower than the numbers that we were actually interested in the DCRLs. So in this context, we've actually got numbers here for the fish where we know we have impacts, but they're actually lower than the DCRLs that we're actually using as our bands of protection or where we're looking to work with. Again, summarizing this quickly, the human impacts were all, the human dose assessments were all within the standard criteria that were being applied at this site. So there were no issues at this site from human exposure. But as I said, it's complex because you've got these issues of planned and continuing existing exposure situations that were happening. My third case study is actually from Australia, the Little Forest Legacy site, which is in New South Wales. And here we have trenches of waste, radioactive waste that were buried in the 60s. We have a different complex mix of radionuclides here. It's not just cesium and strontium. We've also got americium, uranium isotopes, and other radionuclides that we might be interested in terms of the context. And what's interesting about this site, again, if you do the assessments for wildlife, there were two parts that came out that maybe were worth thinking about in terms of wildlife protection, maybe worth thinking about in wildlife protection terms. And that was for the acacia tree. In this context, it was the acacia tree actually growing into the waste trenches, and once it hits the waste trenches, it's available to take up the radionuclides that are present in the waste trenches, and then you can start to see potential doses that are of the order of the DCRL band. Similarly with frogs, off-site of this location, there's a leach where the leachate passes into. If you assume there's water there, then you can potentially have amphibians growing in that environment and so on. And those frogs, the adult frogs, will give rise to tadpoles, and it was actually the tadpoles where the assessment was potentially saying there may be impacts at the level of the DCRL again for the particular amphibians. Now, that's a very conservative assessment because the water doesn't always present there, etc., and you've got to ensure that the leachate comes down and so on. It was pessimistic in the calculations, but there was a potential for the impact on the wildlife. And in this context around this site, because of the controls that were already in place in terms of human access, because you're not allowed to just walk onto this site, all of the doses for humans were well below 1 millisievert per year. And again, that meant that there was no requirement for even a reference level in terms of dealing with this in an existing exposure situation. But the issue here is that most of the wildlife was below the relevant DCRL, but there were a couple that may need to be considered if you take into account a pessimistic assessment. There were no direct comparisons, as in other sites, where you can look at the wildlife and the humans in terms of the assessments at this site. And again, we might need to think about spatial extent, the number of individuals impacted and so on for this particular site. What I'm hoping I've shown you with all of this is that there is the potential for impacts at existing exposure situation sites, potential for exposure. It's all done on a case-by-case basis, and we need to think about the consequences of these, and that's where the word consideration comes in that I've highlighted in red in terms of the derived consideration reference levels. Doesn't mean that you have to do anything particularly about this for wildlife, but it means you might want to stop and consider what your options are. And if you're doing this on an existing exposure situation where you have human assessments and you're doing something for humans, you might want to consider what the impacts are on your wildlife at the same time. It might not be from radiological parts, it may be from the non-radiological cleanup that you're actually doing on the site. So the point I'm trying to make is that environmental protection may need to be considered as part of the decision-making process for these existing exposure situations. I've said this many times in presentations, some of you may have heard me say it before. Probably for most planned exposure situations, we don't need to worry too much about biota assessments because they should be well controlled at the best of times. What can we learn from this? Well, I think there are a number of things that you can take from this. You need to think, as I've just said, when you improve the radiological situation for humans, you will almost certainly improve the radiological system for wildlife in terms of the radioactivity that's present at that site, because you've removed it. But what have you done in that process of removal? Are there other things that we need to take into account in terms of the physical impact on the biota? In terms of the assessment, how many individuals have been impacted? What's the temporal and spatial scale that I'm concerned about in this context? How big an area am I working in? In terms of the population, how big is the population impact going to be when you have individuals living in around the site that we have? And as I said, this is all a value-laden driven decision-making process and will be highly dependent upon the stakeholders that you are engaged with in that consultation process. But the point is, now you have a way of actually being able to explain what the consequences of your cleanup action in terms of radiological assessments for the wildlife are when you're looking at the justification of the cleanups. And as I said, I'll try and get it the right way around this time. I would suggest that what we want to try and ensure is that when we do this, we're actually making sure that we're doing more good than harm in terms of the wildlife, as well as the humans that we're actually looking for. And what you're trying to do, as I said, by actually being able to do these calculations, is giving ourselves the ability to help explain and justify our decisions in terms of the radiological impact that you have on both the humans and the wildlife. Something to mention, though, just to finish off, we have obviously mentioned the fact that some of these wildlife species are actually exceeding the DCRLs and so on, or actually showing impacts at levels below the DCRLs, where we have situations where the humans aren't actually being impacted in terms of the dose assessment. So what do we do in those cases? Do we actually try and clean up a site on the basis of environmental protection? And I'll leave that to Debbie at the back somewhere to talk about in her ethics talk on Thursday in terms of the ethics of needing to clean up a site and so on. But at least now we have the ability to start having those conversations. Okay, and I think that's me. Thank you very much for your attention.